Good morning everyone, I am Srisaran from Team SimpleVac. We are a students team comprising of students from PhD College of Technology, and our problem statement ID is 1548 and our problem statement title is Development of a Suction Based Low Cost Flush for its deployment in rural areas. So we have come up with this problem statement so that we can come up with a solution for one of India's major problems, which is good hygiene and cleanliness. So we would like to improve the sustainable sanitation access for even the rural areas. So the business strategies we are having for our idea are: we can come up with the commercial base due to the growth of rapid infrastructure even in rural areas in terms of construction of houses, temples, etc. And also we can collaborate with the Gram Panchayats of the country under the guidance of the Swachh Bharat Abhiyan and use the funds provided by the central government to the Gram Panchayats for the construction of sanitation and healthcare amenities. And also more commercially, we can pair with venture capitalists and startup funding organizations to commercialize the idea to get into large scale production so that we can get into our target audience of rural areas in India and other poor countries from Africa and South America, etc. And one of our other business strategies is to club under government initiatives to gain global attention and improve the status of rural sanitation in and around India and also over the globe. So now let's begin with a detailed comparison of the parameters of our idea SimpleVac and the generally existing vacuum based flushing system. So the first parameter to be compared is the operation principle. While our idea is completely mechanical, where the pressing of a pedal placed near the basin initiates the compression and regression cycles of a bellow to suck the waste from the basin, whereas the conventional system uses a electrically powered vacuum generator to suck the waste. And next is the energy sources. While ours is completely 100% energy efficient, the conventional system uses electric power to run the vacuum generator so that the waste can be sucked out. And the water usage. So the ours and the vacuum system are almost similar in case of the usage of water, whereas the synchronized water spray which we use to pre-clean the basin is a much more efficient idea. And next, the mechanical components used. While ours is completely mechanical and totally replaceable, the conventional existing system uses electrical and mechanical components in our place. And next, the durability. While ours is more durable for the rural areas due to its completely mechanical nature and easily replaceable being, the conventional system is not easily replaceable while repairing the vacuum generator is also difficult. And next is the maintenance complexity. Our idea is an easy to understand and even repairable by the layman, while the conventional vacuum based generator using flushing systems are not easily understandable for the layman and it's more difficult to repair. And also the eco-friendliness. Our idea is completely eco-friendly due to its no use of electrical power and easy to attach biocomposting system at the end of a flowchart so that we can generate biomanure. And next, the target audience. While our system targets the rural areas of the country and even the rural areas of the globe, the conventional vacuum generator based flushing system is more appropriate for places where water and electrical supply is more easily available. And finally, let's go into the cost analysis of our system and the conventional toilet. So coming to the components, the water components and the reservoirs used in our SimpleVac toilet come to around 500 to 1000 rupees, and the bellow spring mechanism, which is a key aspect of our idea, comes to about 1500 to 3000 rupees. The initial spray mechanism to wet the basin before usage comes around 500 to 1000 rupees, and the plumbing and other installation parts come around 1000 to 2000 rupees. And finally, the miscellaneous components which will be used as fittings and screws, etc., might come around 500 to 1000 rupees, totally amounting to a total cost of 3000 to 8000 rupees for the SimpleVac toilet. While comparing this to the conventional toilet, the water components and reservoirs itself are larger in size, reaching to amounts about 5000 to 12000 rupees, and the vacuum pump and components at the base level start from 3000 to 7000 rupees, and the flush mechanism itself is 1500 to 3000 rupees. And including the plumbing and installation parts and other components, the total cost of the conventional toilet, which is the vacuum generator powered suction based flush, comes to around 11,000 to 27,000 at the least. So now let's talk about the parts used in our SimpleVac toilet. So coming to the first unique part which we have used, it's the atomizer spray. It's a resemblance of the normally used perfume spray where you press to give a mist of water. But here we have changed the spray to give a much more bigger output in terms of volume and the amount of water sprayed. And the next part is the bellow system. So the bellow is nothing but, as shown in the figure, it's a kind of a spring but made of EPDM, which is ethylene propylene diene monomer, which gives high compression and expansion cycles and gives more life, and is also very cheap. So the next part we have used is a spring. This spring is intertwined between the cross sections of the bellow, which leads to the repetitive usage of the bellow itself and gives us the compression and regression cycles. So the spring is mostly made of high carbon spring steels, which will give us higher durability and cost efficiency. And next, coming to the final unique part of our system, it's the pedal. So the pedal is placed near the base of the toilet, so that user, once usage is complete, can place his foot on the pedal, so that the pedal mechanically compresses the bellow and the spring regresses the bellow, so that the user can keep compressing the pedal to flush with multiple cycles. So moving to the workflow action of our system, let's begin with the first stage, which is the pre-use atomizer spray stage. So when the user sits on the toilet bowl before usage, a mechanical trigger activates the atomizer spray, which is nothing but the seating pressure of the user itself. This wets the inner surface of the bowl by using a minimal amount of water, around 50 to 100 ml per usage. The fine mist produced by the atomizer ensures even wetting of the surface without oversaturation and waste of water. And the next stage is the after use flush trigger, which consists of the main flush pedal and the suction mechanism. So this action is as follows. Once the usage of the toilet is complete, the user steps his foot on the pedal, and that compresses the bellow system, so that the pedal mechanism is similar to that of the pedal air pump mechanism. This compression action creates a suction which will suck out the waste and other water from the basin. And this system is made so that the stagnant water is able to refill. That is, after the suction process is complete, the water flow continues for about 2 to 3 seconds extra to refill the stagnant water level in the bowl, so that odors are prevented and hygiene is maintained. So the water usage of the refill uses around 500 ml, so that the bowl has sufficient water for the next usage. And next, coming to the composting tank which is an optional idea for the system, we can add the composting tank at the end of the flow cycle, so that after flushing, the waste is directed into a composting tank where it decomposes naturally. This reduces the need for external sewage systems and provides an eco-friendly waste management directive. And also the biomanure can be generated from this composting tank, which will be much useful in rural areas where agriculture is preferred. So this is the pictorial representation of our workflow, and here you can see in the picture of the bellow that we have provided one-way valves at the beginning and the ending of the bellow, so that backflow is prevented. So now let's move on to the calculations regarding our model. So the first thing to be calculated is the pressure for suction. So the bellow mechanism, medium-sized bellow system, which we mostly use, could display around 2 to 3 liters of air, which should be enough to create suction and assist with waste removal. And the pressure required for this bellow can be calculated as follows. And here you can see the average pressure differential for the system would be around 10 to 20 kilopascals, and therefore calculating with the area, which should averagely be 0.008 meters squared, the force would amount to pressure into area, giving us 80 newtons. So this 80 newton can easily be provided by the average human by just placing his foot on the pedal. And next, moving on to the bellow volume. So assuming that the bellow could displace around 2 to 3 liters of air, it would be around 2000 centimeter cubed. And so the volume, the formula used is pi r square h, as you already know. We are getting a probable radius of practical size, which would be 5 centimeters. So the height of the bellow, which can be calculated from this, would approximately be 25.5 centimeters when in the fully extended state. And the compressed height, that is the length of the bellow when the bellow is completely compressed, would be around 6.4 centimeters. Moving on to the next set of calculations, we would like to present the amount of water saved by using our model in place of the conventional toilets. So calculating around 6 liters per flush and 5 flushes per day for just 20% of the population of India, which should amount to about 280 million people, the total water used would be 3.066 trillion liters per year. But using our system, which uses only 1 liter per flush approximately, and using the same amount of 5 flushes per day and 20% of the Indian population, the amount of total water used by our system would be 511 billion liters per year only. So the total water which we can save by just replacing the existing system with our system, or just the rural areas, which is just 20% of the population, by replacing with our system, would be around 2.555 trillion liters per year, which is a much larger amount than the total water consumption of a few smaller countries. So the final thing to be considered in the calculation is the impact on groundwater levels because of our system. So our system slows down groundwater depletion, especially in urban cities like Delhi, Bengaluru and Chennai, etc., which acts as an extended advantage of our system, so that it can be implemented in urban areas too. And also we can help to conserve surface water resources due to the reduced water consumption. And also additionally, the water present in the bio tank, that is the composting tank which we have added optionally, can also be sent back to the ground, which can be filtered easily by the ground itself due to the presence of only organic wastes in the material. So now let's discuss about the future plans we have for expanding our project in the future. So the first one we have is the usage of substances like Teflon to coat the basin of the toilet, so that the adhesiveness of the basin is reduced, so that the same flushing and cleaning properties can be achieved with the lesser usage of water. And the second idea we have is to implement a good design and proper implementation of biogas or biomanure generation from the additional composting tank which we have attached at the end of our workflow, so that we can make the rural areas much more energy independent, and the use of biogas can be more useful. And the final idea we have to expand in the future is to slightly electrify the components of the SimpleVac toilet, so that it can be adapted for the urban areas as well, and make the pedaling action to be removed, and the motor can be used to activate the Bellow system.